Hello everyone, I'm Frank and welcome to Learn How to Sudoku, where we take a very easy variant Sudoku puzzle and we break it down in detail so that you can learn how to Sudoku. Today's very easy puzzle is called Australia in the Fog by Carmen Lambert. And here are the rules. We have normal Sudoku rules apply, which means in every cell in the grid, place a single digit such that every row, column, and designated 9-cell region contains the digits 1 through 9 exactly once each. We have digits along a red parity line must alternate between odd and even. So for example, if this were an odd digit, this would have to be an even digit because they are neighboring digits on a parity line. We have adjacent digits along a green German whisper line must have a difference of at least 5. And I call these whisper 5 lines, not because I'm coming up with it. A setter came up with this name, and I thought it made sense because it's very extendable. So anytime I say whisper 5, know that's basically the same thing as a German whisper line. So, for example, say we had a 3 here. Then that would mean that this digit would have to be 8 or 9. Well, actually, I guess let's make this a 3 here. If we had a 3 here, this would have to be 8 or 9. Oops. Okay, I forgot about that. This is fog of war. If we have a 3 here, this is 8 or 9 here. Ignore that. And because the only digits which are 5 or more away from 3 are specifically 8 or 9. And that's an example of how German whisper/whisper 5 lines work. We have digits along a magenta red band form a set of consecutive, non-repeating digits in any order. So we have right now, this is part of a ren band here, but we don't know how large it is. Say it was just these 3. Then you could have something like, say, 2, 3, and 4, and this would be valid as a ren band because they form a set of consecutive, non-repeating digits in any order. You could not have, say, something like 2, 3, and 5 here, though, because that would not be consecutive. But if we extended it, say this was like more than 3 in size, you could have a 2, 3, 4, 5 set that could potentially work. And those are examples of how Renban lines work. We have digits along a blue line create a sum line where the sum of digits on a line within a particular 3x3 box must be the same for all the boxes the line passes through. So say we had, I guess this is, yeah. Say we had a line something like this, then the digits here would have to add up to what the digits along this section must be. And I prefer the rule explanation where it's saying box borders divide the line, or region borders divide the line into segments, all of which must sum up to the same sum. So if the box borders divides this line into segments, this is a segment, and this two forms a segment, which must sum to the same sum for each segment, right? So for example, if this were say 2 and 5, then this half would have to be 7, because these must sum up to the same sum, and these are different segments, right? This is a segment and that's a segment because of how the box borders divide the line. And this is otherwise known as a region sum line. So that's an example of how a region sum lines work. We have digits along an orange Dutch line must have a difference of at least 4, and I call these whisper 4 lines. Notice the extensibility here. You can extend this to 4, whisper 5, whisper 3, whisper 6, however you want it, right? I don't know how extendable country lines are, but people will just argue with me about that. Anyways, so for example, if this were say a 3 here, this would have to be 7, 8, or 9 to be next to it on the whisper 4/Dutch line, Dutch whisper line. Yeah, I think they meant to say Dutch whisper instead of Dutch line because Dutch line is not known as a rule set at all. Anyways, those are examples of how a whisper force, or otherwise known as a Dutch whisper line, work. We also have a white dot between cells indicates cells with consecutive values. Not all dots are shown. So for example, if this were, say, a 3, then this would have to be 2 or 4 to be consecutive with that 3 that was there. A V between two cells mean they add up to 5, and an X between two cells mean they add up to 10. So, for example, say this was a 3 here, then this would have to be 2, because these two digits must add up to 5. If, say, this was a 9 here, this would have to be 1, because these two digits must add up to 10, because there's an X between them. The board is covered in fog. Place the correct digit correctly, and the fog will lift around it. And so this is standard fog of war puzzles, where basically if you place the correct digit, it will clear the fog in that cell and in the 3x3 box that surrounds that cell. So that's I guess I think standard or typical fog of war is what I call it. And this is a puzzle for my husband, who is Australian, for Australia Day. This is actually well after that, but because I tend to do puzzles well after they're posted, because I need a sort of supply of puzzles that I can do, so that I don't have to do every puzzle the day of. Anyways, happy belated Australia Day for you Australians out there. It's a lovely country. I've visited there multiple times, and I enjoyed it. Wait, is it multiple or just once? Maybe it's just once. I went to a lot of places, I think, in Australia, though. I went to Cairns, I went to Sydney, I went to Melbourne. I guess that's not that many places. But it was like a good 3 weeks. It was nice. It was very, very beautiful country. Anyways, those are all the rules. If you'd like to play along, there's going to be a link in the description. And now, I'm going to get started. Let's learn how to Sudoku. Okay, we have a Whisper 5 line. Okay, we have a V here. Therefore, these digits must be from 1 through 4. Which, in normal Sudoku with Whisper 5 lines, I like to designate 1 through 4 as low digits, and therefore blue cells. And the high digits, which are 6 through 9, I like to designate as red digits. On a Whisper 5 line, you'll always alternate between low digits, which are 1 through 4, and high digits, which are 6 through 9, because what digits can be next to a low digit? Well, 1 can be next to 6 through 9, which are high. 2 can be next to 7 through 9, all of which are high. 3 can be next to 8 or 9, both of which are high. 4 can only be next to 9, which is high. So you'll always alternate between low digits and high digits. And it's the same way for 6 through 9. 6 can be next to 1, 7 can be next to 1 or 2, 8 can be next to 1, 2, or 3, and 9 can be next to 1 through 4, all of which are low. So a high digit will be next to a low digit. So since this is low here, this must be next to a high digit here, which makes that next to a low digit here, which makes that next to a high digit here. Well, the only digits which can be add up to 10 and have to be at least 5 or more apart from each other is 1 and 9 and 2 and 8. So this has to be 1, 2 with 8 or 9 here. Therefore, and this has to be 1 through 4 here, 1 through 4 here. So this digit also must be 1 through 4, but it can't be 1, because if it were 1, it would have to be consecutive with 2 other digits. And 1 is only consecutive with 1 digit, which is 2. So this cannot be 1, which means this can't be 4 to add up to 5. This can't be 1 either, so this has to be 2, 3, or 4. Interesting. Okay. So these 2 digits are the same, we know, because they add up to 5 with the same digit here. So these are the same, so I guess we'll mark them as A. If this is 2, that would guarantee this is 1, so this could not be 1. But we know 2 and 3 add up to 5. So this cannot be 2 here, because if this were 2, that would force this to be 3, this to be 1, and this could not be either 1 or 3, which must be consecutive with 2. So this can't be 2, which means this is guaranteed to be 1 or 2. That eliminates 1 and 2 in the rest of the box and the rest of the row. So this can't be 2. This is 3 or 4. If this is 3, that would guarantee 2 here. So if this is 3, this has to be 4 here to be consecutive with it. And then this would be 2. If this is 4, this would have to be 1, but this could be 3 or 5, and this could be 3 or 5. Interesting. So we're guaranteed a 4 has to be one of these digits here. And they are different parity here. These are also different parities. Okay, does that tell us anything? We're guaranteed a 4 here, which means the rest of the box cannot contain a 4. And we can't have 1 and 2 because of the 1-2 pair in the box, so that means we have 3, 5, 6, 7, 8, and 9 here. Okay. So we know that these 2 digits, which are next to this digit, so 5 can only be next to 1 and 9 on a whisper 4 line. So this cannot be 5. Therefore, this has to be a 3-4 pair, which eliminates 3 and 4 in the rest of the box. This digit, then, is 3 or 4, and it's next to 2 unique digits on a whisper 4 line. So it has to be at least 7 or higher. So this has to be 7 or higher, next to 3 or 4. It has to be next... We have a 7, 8, 9 triplet in the box now, which means this has to be a 3. Because it has to be guaranteed next to be a 7, and only 3 can be next to that. And that also, this eliminates 7, 8, 9 here. Therefore, this is 3, which makes this 4, which makes that 1. And this is 2 and 8 to add up to 10. So no 8 here, no 8 here. This is 7, 9 as a pair. Which works here because 7 and 9 are odd. 2 is even. 4 is even. This guarantees this is... So this is a 4 here. 4 and 6 add up to 10. And 4 and 3 are consecutive. 4 and 5 has to be the remaining consecutive digit. 7 or 9 is here, which is consecutive with 6 or 8. So that's fine. 2 has to be next to 7, 8, or 9. This is guaranteed to be a low. So it's 1 through 4. We have 1 and 4 here. 4, and then this is parity line, so this is an odd digit. So we have 1, 3, 7, 9 here. Therefore, this is even digit, and it cannot be 4 and 6 because of 4 in the box. So this is 2 and 8 guaranteed here. And this is consecutive with another odd digit, which would be 1, 3, 7, and 9. 1, 3, 7, 9 adds up to 10 with another odd digit, and this digit is 4 or more away from 7 or 9. So it cannot be 7 or 9, because if this were 7 and 9, it would guarantee not be 4 or more away from 7 or 9. This can't be 2 because of 2 in the column. Okay, this is consecutive. We don't know how long this Renban line is, though. Remaining digits in this right central box cannot be 2 or 8 or 4 or 5, so it has to be 1, 3, 6, 7, or 9. And this can't be 1 and 1 because of 1 in the row. This is 1 or 3, which must be must add up to 10 with 7 or 9. We have a 7-9 pair now in row 6, which eliminates 7 and 9 in the rest of the row, so this can't be 7 or 9. This is 1 or 3, which must be consecutive with this digit, which is even because of the parity line. So this has to be 2 then. 8 is not consecutive with 1 or 3. So that's 2. This is 8. Okay, so this is a 6 length Renban. So we cannot have 7 and 9 with 1 and 4. So this is 3, 6 as a pair, which eliminates 3 and 6 in the rest of the box. This can't be 3. This is 1. This can't be 1, 3, or 6. It's 7 or 9. Well, 6 is not 4 or more away from either 7 or 9, so this can't be 6. This has to be 3, which makes this 6. 8 eliminates 8 here, so this is 6, which means it's consecutive only with 7. So that's 7. This is 9. 7 eliminates 7 here, so that's 9. 7 is 4 or more away from 1, 2, and 3. And 1 and 2 are eliminated because of the 1, 2 in the row. This 9 also eliminates 9 here, so it's 7 and 3. This must therefore be 3 to be 4 away from 7. 3 can only be next to 7, 8, or 9 on a Whisper 4 line, and 7 and 9 are eliminated because of 9 and 7 in the row. So this is 8, this is 4. We have 1 and 2 remaining here, so either of these could be 1 or 2. The remaining digits in row 4 are 5, 7, 9. Okay. This is 1, 4, 3, 4, 6, so that leaves this as 2 and 5 remaining. 5 on a Whisper 4 line can only be next to 1 and 9, and this digit cannot be 1 or 9 because of 1 or 9 in the column, so therefore this must be 2 here. This is 2, this is 5, and we're seeing the outline of Australia here with, I believe, this is Sydney, this is Melbourne here, Cairns was around here. And then we have Tasmania here. This is the... I don't remember what it's called. Queensland, I think? I don't remember. My geography of Australia is not that great, I will say. Anyways, let's continue with this. 3 can next be next to 7, 8, and 9 on the Whisper 4 line. It cannot be 8 here because of 8 in the column. Remaining digits of column 7 are 1, 2, 8, and 9. 8 and 9 cannot be next to 7 or 9 here on the Whisper 4 line because it's less than 4 or more away, and this can't be 2 because of 2 in the row, so this is 1. Therefore, we have 2, 8, and 9, 2, 8, and 9 remaining in column 7. 1 and 2 have to be next to 6 through 9 on a Whisper 4 line, and it cannot be 9 because of 9 in the column. 2 is next to 6 through 9 here. Cannot be 8 because of 8 in the column. 6, 7, and 9 can be next to 1 through 5 here. Cannot be 2 or 5 because of 2 or 5 in the box. So we have 1, 3, or 4 next, and 1, 3, or 4. So this must be at least 1 and 3. 1 and 3 have to be next to 7, 8, or 9. The 7 eliminates 7 here, so this must be 8 or 9 here, next to these 2 digits. Well, actually, we're not guaranteed that. So this could be 6, 8, or 9 there. Well, we do have a 6, 7, 8, 9 quadruplet in this upper central box, so this can't be 6, 7, 8, and 9. It's 1, 3, or 4, and therefore is a low. So these are lows, and these must all be highs. This is low. We have low here. This is high. 2, 8, or 9. 1 and 3 have to be next to 7, 8, or 9 here. Cannot be 8, so it's 7, 9. We now have a 7, 9, 7, 9 pair in column 8, which eliminates 7 and 9 in the rest of the column. That leaves the remaining digits as 1, 3, 4, and 5. Well, 1 can't be here because of 1 in the box. 3 can't be here because of 3 in the box. We're guaranteed a 1 has to be one of these two digits. And 1 cannot be 4 or more away from 4. So it has to be 1 and 5 here, which eliminates 1 and 5 in the rest of the column. So this is 3, 4 as a pair. 1 and 5 both cannot be next to 2. They have to be, 1 and 5 have to be next to a 9 to be 4 or more away from it. So this is 9, which eliminates 9 in the column. And 9 in the box. So this has to be 7, which makes this 9, which eliminates 9 here. So that's 8, which eliminates 8 in the rest of the... Oh, we knew this, yeah, had to be 5 or more away from this digit. Well, 6 can't be here, because 6 would require 1 to both be in these boxes, and it's not allowed, so this has to be 9. So this is 9, which eliminates 9 here. 1 eliminates 1 here, so it's 3 or 4. 9 can be next to 1 through 5 on a Whisper 4 line, and this 3, 4 pair eliminates 3 and 4 in the rest of the row, and it can't be 1 or 2 because of 1 and 2 in the row. So this has to be a 5, which is next to 1 or 9. Cannot be 9 because of 9 in the row, so this is 1. No 5 here because of 5 in the column. 1 eliminates 1 here. Where is the 1 in this upper central box? It has to be here. So this is 1 there. Okay. 1 eliminates 1 here, so this is 2, which makes this 1. These digits are consecutive. Remaining digits in row 2 are 6 through 9. No 9 here because of 9, or no 6 here either, because of 6 and 9 in the box. No 8 here because of 8 in the column. This could be 5, 7, or 9, so that still satisfies that. Remaining digits, okay, so these add up to 10. These add up to 10, and cannot be 3 or 7. 8 cannot be here, so this can't be 2 or 8, so this is either 1, 9, or 4, 6, and 1 cannot be here, 9 can't be here. Remaining digits in this column, 6, are guaranteed to be 3 and 8 with 6 or 7. There's no 3 or 7 here, so this has to be 6 or 8 here. Remaining digits here, this cannot be 2 and 8, because both 2 and 8 would eliminate this as a possibility to be 2 and 8 here, which only adds up to 10 this way. So this has to be 1 and 9, or 4 and 6, with no 6 here, no 4 here then. This can't be 9 because 9 is only consecutive with 8, and we already have an 8 in the column, so this must be 6 and 4. So we have 6 and 4, 1 and 9. 6 is consecutive with 5 or 7. And 6 eliminates 6 here, so this is 8, which eliminates 8 in the rest of the column. This is remaining digits in row 7 are 2 and 5. And 5 cannot be here because of the 1, 5 pair in the box. So this is 2, which makes this 5, which makes that 7. This 2 eliminates 2 in the box, so that's 8 and 2 there. This 7 eliminates 7 in the row and 7 in the column. And we have a region sum line here. I wonder why that's, I'm trying to figure out where that occurs in Australia, but, where is the 5 in this upper right-hand box? Cannot be here because of 5 in the row. So this must be 7 or 8. Cannot be 8 because of 8 in the row. So this is 7, which makes this 8, which makes that 5. Remaining digits of column 9 are 4 and 6. Okay, that doesn't help too much. We have 4 and 6 here, 4 and 6 here. This 3 eliminates 3 here, so this is 4, which makes this 3. Oh, this had to be 3 because it's in between 2 unique digits on a Whisper 5 line, and 4 cannot be next to 2 unique digits. 3 eliminates 3 here, so it's 4 and 3. 8 eliminates 8 in the row. 5 here eliminates 5 in the column, so this is 7 or 9. We have a 7-9 pair in row 4, which eliminates 7 and 9 in the rest of the row, so this has to be 5. Okay. Remaining digits of... Let's do column 2. We have 3, 6. This 6 eliminates 6 here, so this is 9. Okay, well, that's helpful. So that eliminates 9. We just have 3 and 4 remaining. This can't be 3 because of 3 in the row, so this is 4, which makes this 3, which eliminates 3 here. Where is the 3 in column 6? It has to be here. So we know these two digits add up to the singleton digit here. So these cannot be 1 or 2. Remaining digits in this lower left-hand box are 1, 2, 8, and 9. This can't be 1 or 2 because it's a sum of 2 unique digits. And it can't be 8 because of 8 in the row, so this must be 9 here. Therefore, these two digits must add up to 9. 1 can't be here anymore in this lower left-hand box because of 1 in the column, and 1 can't be here because of the region sum line. So this must be 1 here, which makes this 5, which makes this 1. This has to be 2 and 8 as a pair, and 8 cannot be here because of 8 in the row. So this is 2, this is 8. Therefore, this cannot be 2 and 7 adding up to 9. It cannot be 1 and 8, cannot be 3 and 6. It has to be 4 and 5. So 4 has to be here, 5 has to be here, which eliminates 5 here, so it's 6, which eliminates 6 here, so it's 5. 6 eliminates 6 here, so it's 7, which makes that 6. 7 eliminates 7 here, so it's 6. So remaining digits, 6 eliminates 6 here, so it's 7. 4 eliminates 4 here, so it's 6 and 4. We have just 2 and 6 remaining here. So this is 2 and that's 6. Excuse me. 9 here eliminates 9 in the column, so this is 7 and 9, and then we have 2 and 5 remaining in column 3. No, not 2 and 5. 2 and 8 remaining in column 3. This can't be 8 because of 8 in the row, so this is 2. This is 8. That leaves this as a 7, and this as a 3. Right. Okay. I guess I'll just read what it says. Yay, you completed the puzzle. If you got here via Logic Masters, click on the back arrow and click on the word here to see the picture without numbers. For more of my puzzles, Google Logic Masters fog pictures. So, nice little plug for the setter. Yeah, I just mainly chose it because of Australia, because I had good memories of going to Australia. So many that I thought I'd been there multiple times, but I've only been there once thinking about it. Anyways, I hope you enjoyed this episode of Learn How to Sudoku, and I'll see you next time on Frank Puzzles. Take care.